All right, hello everybody, and welcome back to a new section in chapter 4. So this time we're talking about parallel and perpendicular lines. So these are two special cases of relationships between lines. We'll look at how they relate to each other and how we can understand those in some problems. So before we know, we worked on point slope form. And now we're going to be able to write an equation of a line if we know it's parallel or perpendicular. We'll be given some information, maybe a point, and then we'll be able to write those things. So the two keys today, we are focusing on two types of situations. One where you have two lines that are perpendicular to each other. We use this symbol to mean perpendicular. And two lines that are parallel. And we know parallel is like a railroad track. You'll see this symbol to mean parallel. Two lines going off in the same direction. So perpendicular, they intersect in a T. Parallel, same slope. Now our vocabulary, we know parallel and perpendicular are what we are focusing on today. So in our first example here, we want to write the slope-intercept form for an equation that passes through this point. So they give us a point. And they also tell us it's parallel to this graph. So what are they really telling us here? Well, they give us a point, so that's okay. That's something to think about. But they tell us it's parallel. The line we want is parallel to this line given. So parallel means what? Well, we know parallel means they have the same slope. I'll put an m. They have the same m value, the same slope. So if m in this equation is 1/2, that's my m value, then I know the line parallel to it has the same m, so it's also 1/2. So now we're back to the previous section where they told us we have a line with a slope and a point given, and then find that equation. So here's what we just said. We know it has a slope of 1/2. So we can replace m with 1/2. And we know we have a point given, that's an x and a y. So we can use all of these things to find our point slope form, just like we did in the last section. So, have that piece ready, these numbers and the equation, as we pass to the next part. Now, point slope form is given here. That's our blank equation, so we start there. Notice the three things here in color are the things that we need to sub in. What is our slope? What is our y value point and our x value point? Those three things plugged in, we can then write that equation. So we had those from the last slide. So we said m was 1/2 since we knew it was the same as the previous line. Our y value is a -2. X value is a +4. Now we just substitute those in. Now we would leave this as is, but there's one thing that we do want to correct, and we talked about that before, and that is the double negatives here. So we don't want double negatives, so we'll go ahead and change that to a +2. So we get y plus 2 here. Everything else here, notice that it stays the same. And then we'll go ahead and leave that equation as is. That is perfect for what we want to write. So this would be it for point slope form. This is where we stopped at. This step is what we stopped at in the last section, right here. But if we go back to our instructions, they actually want us to write our equation in slope-intercept form. So given that, we know slope-intercept is going to have us solve for y. So even though we would normally stop here for point slope, we need to keep going and get y by itself to get that in slope-intercept. So we'll subtract 2 from both sides, like we see here. And then one more simplification, we'll get y by itself on the left because these 2's cancel out. On the right, we'll get 1/2 x, take away 4. So this is now the final equation given all that info. Y equals 1/2 x minus 4. So they're going to tell you either your line is parallel or perpendicular to a line given. That's going to cue you in on what the slope should be. Okay. So here's another one to think about. Similar logic. They ask it for our equation here. They want it in slope-intercept form, which we know is y equals mx plus b. Slope-intercept, slope is m, intercept is b. This is that form. What else do we know here? They give us another equation here, and they say it goes through this point given, and the line we want to write is parallel to this equation. So this got shifted off for some reason, but we know it's parallel to the graph of y equals 1/2 x minus 1. So we said before, parallel means same slope. So it has the same m value. So if that we know is true, what is the m value given in this line that we're comparing to? Well, the m is attached to x. So we know in this case that is 1/2. That's my m. So what we really know is that the line that we want to write, this m value is 1/2. So I'll start with what we know. We know y equals 1/2 x and everything else we don't. So mx plus b is what we're looking for, right? Okay. We plug in the m value that we just found. That gives us 1/2. And the other thing we know we need to find is b, right? M and b, we need both of those to write our equation. We've talked about this many times. So we find the 1/2 for m, but how do we find the b? Well, we need to substitute in an x and a y, right? So here's an x, here's a y. We need to substitute both of those things in to get this equation the way we need it. So where I see a y, I'll put a 3. Where I see an x, I will put a 2. And now I can solve for that b value. So 3 equals, I will change 1/2 times 2, I know it's just 1, plus b. So 1 plus some number equals 3. What's that some number? If you don't know, you can subtract 1 from both sides, and b would equal 2. So, since b equals 2, we know that we can find m and b in this equation. So if I change this, I know y equals, we said m was 1/2, we found that here, and b is 2. So we have 1/2 x plus b, we said, is 2. So given this as our equation, do we see that as an option choice? And it looks like that is definitely C. So for 1B in today's notes, please have down y equals 1/2 x, add 2. So as we're working through these and we confirm with the red circle, we're going to need to pay attention to the difference between parallel and perpendicular, and then know what those words mean. What are they hinting at for us to know? So here's a real example with a bit of context and a graph to look at. So it will be helpful to draw yourself a picture. It does not need to be exact, but it will be helpful to draw yourself an image of this so we can compare that and have that for a part of our discussion. So you're going to need to draw yourself a rectangle with 2 diagonals going across, and then we'll talk about those values. So what are we being asked on this problem? They want us to determine whether the line JL is perpendicular to the line KM. That's what these mean when they have a bar over the top. That is the line segment with those letters. So JL is this line here. They say, is that perpendicular to KM? KM, if we track that, is the diagonal going the other direction. So are these two lines perpendicular is the question. So how do we know if two lines are perpendicular? Well, we know their slopes would have to multiply. Their slopes would multiply to a -1. So we know their slopes would have to multiply to that -1 value. But how do we know that? How can we check that? And the answer is we have to find the slope of each line individually, and then we can multiply them together to check. So given 2 points, we can find the slope. So I can find the slope of JL. That's going to be equal to the difference in the y's. So I can do 6 minus 1, which is 5, over 2 minus 6, which is a -4. So I get a -5/4 for the slope of JL. Now let's find the slope of KM with the same process. So we know we've done this many times. The slope is the difference in the y's, so 6 minus 1, over the difference in my x's, so 6 minus 2. So I get 5 over 4. Now if I were to multiply these two together, what would I get? Well, if I were to multiply these two, I would not get a -1. Instead, I would get a -25 over 16, which we know is not a -1. So since that's not a -1, we can say no, these are not perpendicular lines. It's perpendicular, we know, has to multiply to a -1 value, exactly -1. So easily enough, the answer to this real context problem, these two lines are definitely not perpendicular. So now, here's an example 3 problem to look at. We want to determine whether the graphs of these 3 lines given are parallel or perpendicular. So the way we're going to do that is to compare the slopes of each one, and then say if any of them are the same, we can say those 2 lines are parallel. And if any of them multiply to -1, we can say those 2 are perpendicular. So one way you could do this, you could do algebra or a graph or both. So one way to look at it is in a graph. So say we were to graph all of these, we would get this image here. Now once you have the image, it becomes very, very easy to see which 2 lines are parallel, because they look like railroad tracks. They never touch, they don't intersect. So we can see straight away that this red line and this green line are indeed parallel. They will never intersect. We could solve this equation for y, and we would see the slope is the same, is both 1/3. Now we would also want to be able to check to see if this line is perpendicular to either of these, and we could do that by comparing the slopes. So I know this one is already in great shape because I can tell what my slope is. So for this first one, we have m is 1/3. For my second line, what is my m value? If I'm now looking at this line, what's m in this equation? Well, I need to move this around and solve for y. So if I did that, I would have y equals a -3x plus 12. Just one step of subtracting 3x from both sides. So the slope here is actually a -3 then, the number attached to x. That's my m. So m for this one is a -3. What about for the third line if we compare? Well, this third line, we're also going to need to look at how to get y by itself. So if we shuffle this around, we would get -6y equal to negative 2x minus 5. And if you divide everything by negative 6, y would equal 1/3 x plus 5/6. So again, we know the slope is a number attached to x. So in this case, that is a 1/3. So now, if we compare the slopes, we can see what's happening here. These two, 1 and 3, are the same. That's these two lines. They both have the same slope, so we can say they're parallel. Then this other line is a negative 3. If you multiply that by a 1/3, you get negative 1. So this line, which we see here, is in fact perpendicular to both of the others. So we just confirmed that with our slopes here. So our answer, given these equations, is going to be, now please have these equations down and our slopes for these. So we have 2 1/3 and 1 negative 3. You don't have to worry about the picture, although it is helpful to have. So our solution then, we see that 2 are parallel to each other and the third is perpendicular. So you don't have to worry about all of these words here, but it is important to understand. Just have down something along the lines of 2 of them are parallel, the third is perpendicular. So we know parallel have equal slopes and perpendicular have a product of the slopes of a negative 1, which we see here with 1/3 and a negative 3. So here's another we can look at, and we've opened up our image to make it a little bit bigger as we compare. So we want to know what, if any, are the relationships here between any of the lines being parallel or perpendicular. Well, I'm looking at my graph and I can tell straight away none of these lines are parallel to each other because they have all different slopes. This one has a slope of 0 since it's perfectly flat. We learned that lines that go up to the right have positive slopes, so this one's a positive number. And our blue line here goes up to the left, that has a negative slope. So none of those slopes are the same. Now the question becomes, are any of them going to be perpendicular? So another way to think about perpendicular lines is that they intersect and form right angles. So clearly this green line does not intersect and form right angles with any of these lines. But the red line and the blue line look like it could be close. Those may in fact be perpendicular. So the way to check that is to compare the slopes and see if they would multiply to negative 1. So if I change my color back here, I see I have a negative 2 here, negative 2 for my slope on this line. What about my red line? What is my slope for this equation? Well, I would need to get y by itself. So if I did a little bit of algebra work, I would see that negative 2y equals negative x minus 4. And if I divide everything by negative 2, y would equal positive 1/2 x plus 2. So the crucial piece here is the slope. So the slope is the number attached to x. In this case, a 1/2. So we have an m of negative 2 and an m of a positive 1/2. Now what do we get if we multiply negative 2 times 1/2? Well, that becomes a negative 1. So since if we multiply these, the slope here and of the red line, if we multiply those slopes, we get a negative 1. That proves that these two lines, in fact, intersect and form right angles. These lines are perpendicular. So anything that says none are perpendicular is wrong, so this one's out. D is out. We know one set is perpendicular, and that set is y equals negative 2x plus 1, that's our blue line. And the red line, x minus 2y equals negative 4. So our solution should be A, given these choices. One set was perpendicular, the blue and the red. Nothing else was special, just that one. So have this piece down. These two were perpendicular. and none were parallel. So have that piece for 3b. Again, don't worry about the image, but if you have that down, that is more helpful as you reflect on your notes. So do we confirm? And yes, we see A was in fact correct. So one fourth type of example to look at. We can find some information given a few pieces. So they ask us here to write an equation in slope-intercept form for the line that passes through a given point and is perpendicular to another graph. So you're going to need this equation and this point for this one. So our first step, find the slope of the line by solving for y. So we have to shuffle this around and get y by itself. So original, we want to subtract the 7x away from both sides. So if we subtract the 7x away, what do we get? This goes away here. We get a negative 7x on the right. So now we're at this step. Now one more thing, we need to get this negative 2 away. We don't want that. We want just 1y. So how do we do that? We divide. So y would equal, with a division to everything on the right, a positive 7/2 x plus 3/2. So this is the equation that you'll need to have down as we progress past this example. So they wanted it in slope-intercept form. So is this in that form? Well, yes, we have the slope and we have the intercept. So that is perfectly solved for y. This should be our solution. So the first piece we did here was to find this equation, solve it for y so we could find out what the slope is. So the slope for this line given is 7/2. But they tell us the line we want is perpendicular to this one. So what is a slope that's perpendicular to 7/2? Well, that would be a number that multiplies to -1 with 7/2. So 7/2 times what number would multiply to -1? Well, it would be the reciprocal of that. -2/7. That would equal a -1. So the slope of the line that we want is going to be -2/7. That's the slope of the line that we need to find. So the slope we found for the given line was 7/2. They told us it's perpendicular to that, so we know it's going to be the opposite reciprocal. So flip it and switch the sign. That gives us, this is now the slope of the line we want. Now we have to just write that equation, and they also gave us a point, so we can plug in. We have a point and a slope. Plug those in, get your value. So plug in your slope and your point from your blank equation. You plug all those values in here, and then from here you need to simplify and solve for y to get that in slope-intercept form. So here we get this step, and now the final thing we need to do is get rid of this +1 because we want just y alone. We'd also need to distribute this 2/7 to both the x and the 4. So you don't need to have every step down, but we do need to work through this so we can get to the final solution. So plugging that in, we get here. Now just a couple more steps to finish this problem. Now, we distribute that slope, we get both of these values here. Subtract the 1 away from both sides, and you get your final solution, solve for y. This is the piece you need to make sure you have. We found that slope on the last slide, and now we can solve for that whole thing. And our final solution, y equals -2/7 x plus 1/7. One more example to look at here. We want to follow the same logic here to write our equation in that slope-intercept form. So slope-intercept form, for the line that goes through this point, that's an x and a y. And they tell us again it's perpendicular to the graph given here. So first step, what is the slope of this line given? So if I solve for y in a couple steps, subtracting x from both sides would give me this. If I divide both sides by 4, I know y will equal a -1/4 x plus 12 over 4 is 3. So what is the slope of the line that they gave me? Well, the slope of that line given is actually a negative 1/4. But they tell me the line we want is perpendicular to a negative 1/4. So if the slope given is a negative 1/4, a perpendicular slope would be flipping it and taking the opposite sign. So the slope I want is actually a positive 4. How? Because if you multiply these, it would equal a negative 1. So the slope we want is 4 now. So we have a line with a slope of 4, and it goes through this point. So what is my equation going to be? Well, if I use y equals mx plus b form, I know m is going to be 4. That's the slope I have. My x is a negative 3, taken from the point. My y is a negative 2. And my b I need to find. So b, negative 12 plus b would equal a negative 2. So negative 12 plus what number would equal a negative 2? Well, b would equal 10. So if b equals 10, what's my equation going to be? Y equals, my slope is 4, and my b value is a positive 10. So which answer choice is that? Looks like answer choice B. So have that down. We worked through these examples. We are into this section and ready for some practice.